Hello everyone, I'm Prakya Jain, Assistant Professor, Department of Mechanical Engineering, HIT Mangalore. Today I'm going to discuss about Module 4 of Fluid Mechanics. There's a continued portion of Dimensional Analysis. So topics, Buckingham Pi theorem problems. So let me start with the seventh problem, as I already discussed about 6 problems in previous video. So let's go for seventh problem. Derive on the basis of dimensional analysis with suitable parameters to present the thrust developed by a propeller. Assume that the thrust P depends upon the angular velocity omega, speed of advance v, diameter d, dynamic viscosity mu, mass density rho, elasticity of the fluid medium, which can be denoted by the speed of sound in the medium capital letter C. So here the method they didn't mention whether to solve the problem using Buckingham Pi theorem or Rayleigh method. So you can go with any method, but when compared to Rayleigh method, Buckingham Pi theorem is very easy method. So I'll go with Buckingham Pi theorem. So here we have to derive expression for thrust developed by a propeller. So this like to get expression for force. So in terms of independent parameters, so independent parameters or independent variables here are omega, that is angular velocity, then speed of advance, that is capital letter V, then diameter d, then dynamic viscosity mu, then density rho, and then last one is speed of sound, that is capital letter C. So we can write expression for dependent parameter as a function of independent parameter. So dependent parameter is thrust, that is you can take either, here they mentioned the thrust force has to be taken as P, otherwise you can go with the notation F. So P equal to F of omega comma V comma D comma mu comma rho comma C, or we can rewrite the expression as F1 of P comma omega comma V comma D comma mu comma rho comma C equal to 0. So take it as expression 1. Now we can count the variables here, that includes both independent as well as dependent variable. So total number of variables, so starting with the thrust P, omega, V, D, mu, rho and C, total number of variables n equal to 7. So writing dimensions of each variable, for thrust that is actually equal to force itself. So from Newton's second law, P F equal to ma. So you have to replace F by P here. So unit of F, that is, or P, that becomes m kg meter s to the power minus 2. So dimension becomes ml t to the power minus 2. So then dimension of omega, that is radian per second, angular velocity. Radian has no unit, per second, that is second is unit of time. So that goes to numerator and becomes s to the power minus 1. So dimension becomes t to the power minus 1. Then speed of advance, capital letter V, that is a velocity. So unit of dimension for velocity is Lt to the power minus 1. Then for diameter, dimension is L. Then for dynamic viscosity, unit is Newton second per meter square. So dimension becomes mL to the power minus 1, T to the power minus 1. Then density, as we all know, density is a ratio of mass by volume. So dimension is mL to the power minus 3. Then speed of sound, that is again similar to the dimension is similar to dimension of velocity. So Lt to the power minus 1. So therefore number of fundamental dimensions m equal to 3, because in all variables we can see m, l and t, or at least one dimension in one variable. So total number of fundamental dimensions m equal to 3. Therefore number of pi terms from Buckingham Pi theorem, n minus m. So n here 7, m is 3, 7 minus 3, that becomes 4. So we have to write expression for 4 pi terms. So now equation 1 can be grouped into 4 pi terms as f1 of pi 1, comma pi 2, comma pi 3, comma pi 4 equal to 0. Take it as expression 2. Each of pi term contains m plus 1 variable. So where m equal to number of independent variable, that one should also equal to number of repeating variable. So here out of 4 variables, we have to select 3 as repeating variable. So first one should correspond to geometric property, second one should correspond to flow property, third one should correspond to fluid property. So here we can see the problem. Here it is given omega v d mu rho c. So p cannot be selected as repeating variable because it is a dependent parameter. So the geometric property we can see here, the diameter is there, so we can select with diameter. Then then we can see that for flow property, velocity is there, omega is there, so preference should be given to velocity. So I can select velocity as property corresponds to flow. Then rho and mu, so preference should be given to rho, so rho can be selected as fluid property. So repeating variables are dv and rho. So now we can write expressions for 4 pi terms. For pi 1, that is equal to d to the power a1 into v to the power b1 into rho to the power c1 into p, that's a thrust force. Pi 2 equal to d to the power a2 v to the power b2 into rho to the power c2 into omega. Omega is angular velocity. Then pi 3 equal to d to the power a3 v to the power b3 rho to the power c3 into mu, where mu is dynamic viscosity. Pi 4 equal to d to the power a4 v to the power b4 into rho to the power c4 into c, where c is velocity of sound. So we can express all 4 pi terms in terms of repeating variables. Those are like d, v, rho, and multiplied by one more independent parameter. So first pi term, there's a represented by pi 1. So substituting dimensions on both sides of pi 1. So we have expression for pi 1 as pi 1 equal to d to the power a1 v to the power b1 rho to the power c1 into p. So we can substitute dimension because we have already obtained dimensions for each quantity. So we can just substitute. Pi 1 is dimensionless. So dimension for pi 1 is m to the power 0, l to the power 0, t to the power 0. Then that is equal to l to the power a1 as dimension for diameter is l into lt to the power minus 1 to the power b1. Dimension for velocity is lt to the power minus 1. Then into ml to the power minus 3 to the power c1. Ml to the power minus 3 is a dimension for density. Then into mlt to the power minus 2. There is a dimension for thrust or force. Then equating the powers of m, l and t on both sides. So let me start with equating the power of m. So we can see here m to the power 0 on left hand side. So power equal to 0. Next right hand side we have m to the power c1 and m to the power 1. So 0 equal to c1 plus 1. Therefore c1 equal to minus 1. Then equating the power of l to the power 0 on left hand side. Right hand side we have l to the power a1, l to the power b1, l to the power minus 3c1, l to the power 1. So I can get expression as 0 equal to a1 plus b1 minus 3c1 plus 1. So I can get expression for a1 as, therefore a1 equal to 3c1 minus 1 minus b1. So now equating the power of t. So l to the power t to the power 0 on left hand side, t to the power minus b1 on right hand side, and t to the power minus 2 again on right hand side. So I can get expression as 0 equal to minus b1 minus 2. Therefore b1 equal to minus 2. Now I have values of b1 and c1. b1 equal to minus 2, c1 equal to minus 1. So I can substitute values in expression 2 for a1. So a1 equal to 3c1 minus 1 minus b1. So 3 into minus 1, that becomes minus 3 minus 1 minus of minus 2. So that becomes plus 2. Minus 3 minus 1 plus 2. So value for a1 is minus 2. Now I can substitute the values of a1, b1 and c1 in pi 1. There's a first pi term. I can get expression as pi 1 equal to d to the power minus 2, v to the power minus 2, rho to the power minus 1 into p. So that is equal to p divided by v square d square rho. So I can take quantities with negative powers to denominator, like d to the power minus 2, v to the power minus 2, rho to the power minus 1, that becomes positive. So expression for pi 1 is p divided by v square d square rho. Next pi 2, second pi term. So that is represented by pi 2. So pi 2 equal to d to the power a2, v to the power b2, rho to the power c2 into omega. Now substituting dimensions on both sides of pi 2, m to the power 0, l to the power 0, t to the power 0, that is equal to l to the power a2 into l t to the power minus 1 to the power b2 into m l to the power minus 3 to the power c2 into t to the power minus 1, as dimension for omega is t to the power minus 1. Then equating the powers of m, l and t on both sides. So first equating the power of m to the power 0 on left hand side. Right hand side I have m to the power m to the power c2. So 0 equal to c2, therefore c2 value is equal to 0 only. Then equating the power of l to the power 0 on left hand side. Right hand side we have l to the power a2, l to the power b2, l to the power minus 3c2. So I can get expression as 0 equal to a2 plus b2 minus 3c2. I can rearrange that expression to get a value for a2. Therefore a2 equal to minus b2 plus 3c2. So next equating the power of t. So a t to the power 0 on left hand side and t to the power minus b2 and t to the power minus 1 on right hand side. Then therefore 0 equal to minus b2 minus 1. So I can get a value of b2 as minus 1. So now I have values of b2 and c2. b2 equal to minus 1, c2 equal to 0. So I'll substitute those values in expression for a2. So a2 equal to minus b2 plus 3c2. b2 value is minus 1, minus into minus, that becomes plus 3 into 0, so it is 0 only. So 1 plus 0, that is equal to 1. So there is a value of a2. Now substituting values of a2, b2, c2 in pi 2. So we get pi 2 equal to d to the power 1, v to the power minus 1, rho to the power 0 into omega. So upon rearrangement, taking a quantity with negative power to denominator, I get expression for pi 2 as pi 2 equal to omega d divided by v. So there is the expression for second pi term. Next, third pi term, that is represented by pi 3. So pi 3 equal to d to the power a3, v to the power b3, rho to the power c3 into mu. Substituting or writing dimensions on both sides of pi 3, we get m to the power 0, l to the power 0, t to the power 0, that is equal to l to the power a3, l t to the power minus 1 to the power b3, m l to the power minus 3 to the power c3 into m l to the power minus 1 into t to the power minus 1, as dimension for mu is m l to the power minus 1 t to the power minus 1. Then equating the powers of m, l and t on both sides. First we equating power of m. So m to the power 0 on left hand side and m to the power c3, m to the power 1 on right hand side. So 0 equal to c3 plus 1, therefore c3 equal to minus 1. Then equating the power of l. So l to the power 0 on left hand side, l to the power a3, l to the power b3, l to the power minus 3c3, l to the power minus 1 on right hand side. So expression 0 equal to a3 plus b3 minus 3c3 minus 1. Therefore a3 equal to 3c3 minus b3 plus 1. Then equating the power of t. t to the power 0 on left hand side, t to the power minus b3, t to the power minus 1 on right hand side. So 0 equal to minus b3 minus 1. Therefore b3 equal to minus 1. So I have values of b3 and c3. b3 equal to minus 1, c3 equal to minus 1. So I'll substitute those values in expression for a3. So a3 equal to 3c3 minus b3 plus 1. So 3 into minus 1, that becomes minus 3 minus b3. So minus into minus 1. So plus 1 plus 1. So minus 3 plus 1 plus 1 equal to minus 1. So now we have values of a3, b3, c3. So we can substitute in expression for pi 3. So we get expression for pi 3 as pi 3 equal to d to the power minus 1, v to the power minus 1, rho to the power minus 1 into mu. So that is equal to mu divided by dv rho, taking quantities with negative powers to denominator. So mu divided by dv rho. So there is an expression for pi 3. Next, fourth pi term, that is represented by pi 4. Pi 4 equal to d to the power a4, v to the power b4 into rho to the power c4 into c. So substituting dimensions on both sides of pi 4. So m to the power 0, l to the power 0, t to the power 0, that is for pi 4, there is a dimensionless. Then l to the power a4 into lt to the power minus 1 to the power b4 into m l to the power minus 3 to the power c4 into lt to the power minus 1. lt to the power minus 1 is the dimension for velocity of sound, that is c. Then equating the powers of m, l and t on both sides. First let's go with equating power of m. So m to the power 0 on left hand side, m to the power c4 on right hand side. So 0 equal to c4, therefore c4 equal to 0. Then equating the power of L to the power 0 on left hand side, L to the power a4, L to the power b4, L to the power minus 3c4, L to the power 1 on right hand side. So I get expression as 0 equal to a4 plus b4 minus 3c4 plus 1. Therefore a4 equal to 3c4 minus b4 minus 1. Now equating the power of t to the power 0 on left hand side, t to the power minus b4 on and t to the power minus 1 on right hand side. So 0 equal to minus b4 minus 1. Therefore b4 equal to minus 1. Now we have values of c4 and b4 equal to minus 1, c4 equal to 0. So I'll substitute those values in expression for a4, that is a4 equal to 3c4 minus b4 minus 1. So 3 into 0, that is 0, minus into minus 1, that is plus 1, 1 minus 0, so that is 0 only. Value of a4 is 0. Then value of b4 is minus 1, c4 is 0. So I'll substitute now values of a4, b4, c4 in pi 4. I can get expression for pi 4 as d to the power 0 as value of a4 is 0, v to the power minus 1 as value of b4 is minus 1, rho to the power 0, c4 value is 0 into c. So that is equal to, upon rearrangement, d to the power 0 is 1, rho to the power 0 is 1. So I can take v to the power minus 1 to denominator. So I get expression for pi 4 equal to c by v. Now substituting the values of pi 1, pi 2, pi 3 and pi 4 in equation 2, that is f1 of pi 1, pi 2, pi 3, pi 4, that is equal to 0. So we have values of pi 1, pi 2, pi 3, pi 4. Pi 1 as p divided by v square d square rho, pi 2 as omega d divided by v, pi 3 as mu divided by dv rho, and pi 4 as c by v. So I'll just substitute f1 of p divided by v square d square rho, omega d divided by v, mu divided by dv rho, c by v equal to 0. But we want expression for thrust developed by a propeller. So that is p. So I'll express pi 1 as a function of remaining pi terms, that is pi 2, pi 3, pi 4. So p divided by v square d square rho, that is a pi 1 term, that is equal to function of or pi of omega d divided by v, mu divided by dv rho, c by v. So now I'll cross multiply v square d square rho to right hand side. So p equal to v square d square rho, a function of or phi of omega d divided by v, mu divided by dv rho, c by v. So this is the expression for thrust developed by a propeller. So here don't get confused. Thrust is related to force, not it is not a power. So you have to be careful here while writing dimensions for there's a thrust. So you have to write dimensions of force itself, that is F equal to ma. M unit is kg, a unit is meter into s to the power minus 2. So dimension becomes mlt to the power minus 2. So there's a problem. So let's go for assignment questions. I have given here two assignment problems. So first problem is the shear stress tau in a pipe flow depends upon diameter of the pipe d, velocity v of the fluid, mass density rho, and dynamic viscosity mu of the fluid, and height of roughness of projection k. Using dimensional analysis, obtain the relation for shear stress in a non-dimensional form. So this is a problem. So they didn't mention again here Buckingham Pi theorem or Rayleigh method. So as this portion is related to Buckingham Pi theorem, you can just go with Buckingham Pi theorem because it is easy method compared to Rayleigh method. So I have to get expression for shear stress, that is tau. Unit is Newton per meter square in terms of diameter d, velocity v, mass density or density rho, dynamic viscosity mu. Hope you know all the units and dimensions of these quantities. And one more term, height of roughness of projection. So roughness, you don't get confused. Roughness, height, it is given height of roughness of projection. So height, that is always measured in meter. So dimension of k becomes m only. So you have to just it is L only. Dimension for meter it is L. So you have to just remember it is clearly given height of roughness of projection. So you have to get expression for shear stress tau, that is equal to function of d, v, rho, mu, k. So here variables are 6 minus 3, you are going to get 3 pi terms. So one variable shear stress 1, diameter 2, velocity 3, mass density 4, then dynamic viscosity 5, and projection 6 minus 3. So 3 pi terms, pi 1, pi 2, pi 3. So you have to get expression for pi 1, pi 2, pi 3, and you have to express 5 pi 1 as a function of remaining 2 pi terms, pi 2 function of pi 2 comma pi 3. So second one, show by method of dimensional analysis that for a screw propeller, the relationship between thrust F, torque T, diameter D, speed of travel U, speed of rotation N, density rho, viscosity mu may be put in the form of F equal to rho D square U square pi of rho D cube U square divided by T, comma dN by U, comma rho U D divided by mu. So they defined here torque T. So torque T has unit Newton meter, Newton kg meter s to the power minus 2 into meter. So kg meter square s to the power minus 2. So dimension m l square t to the power minus 2 for torque. Then speed instead of velocity v they have mentioned in terms of u. There's a free stream velocity, capital letter U. Then rho, it is a density. Then that's a mu, that's dynamic viscosity, D is a diameter. So they gave hint as take du rho as repeating variable. Even though if they are not going to give hint also, you can just go through geometric property here. Diameter is given, length is not there. Even if the length also given means you can just go with diameter should be given first preference. Then for flow property, you can see there velocity is there, then n is there. So importance should be given for velocity, that is capital letter U. Then fluid property, that is rho and mu, both are there. So importance should be given for rho. Otherwise you can see the terms inside the bracket as well as outside. What is the common term? One common term is D, other common term is U, and other common term is rho. So you, based on that also you can select repeating variable. Otherwise you have to go with the method of selecting the variables. First geometric property, then flow property, then fluid property. These are the two questions for your assignment. Second problem is very important. So many times they have asked in final exam, as well as it is very important for the internal point of view. Okay, thank you.